So today we will talk about the projectile motion. And what is a projectile motion? Is a motion, a combination of two motions. One of them is uniform motion. Uniform motion and non-uniform motion. Even in this case, those two motions are independent of each other. So the uniform motion is along the horizontal axis, and the non-uniform motion is along the vertical axis. What is projectile motion? Have you seen a projectile motion before in your life? Yes, you have seen it, you have experienced it. When you are throwing an object with a certain angle, then what do you see? So if here is where you are and you are throwing an object with a certain angle, then what do you see is that the object is obtaining something that looks like this. And what this is actually in physics is known as the trajectory of the object. And it is actually a parabola. We have seen this, you have seen this in math. Okay, it is a quadratic function that is going down. So the assumption that we will do on when we are studying projectile motion is that the wind is and the air resistant is not affecting the motion. So if we have an object that is thrown from a certain point, with an initial velocity at a certain angle, then the trajectory in the ideal situation where there is no air resistance and no wind will look like this. And if we are taking into the consideration the air resistance and the wind, then trajectory will be something like this. The maximum is reached at a lower point. So this is max, and this is max. And the range is smaller. How far is it going in the horizontal axis? The range, it is smaller. However, as I said, we will not take those into the consideration. We will see only the case that we have no wind and no air resistance. Okay, so now, since projectile motion is a combination of two independent motions, one of it is along the horizontal and the other one that is along the vertical, then the best that we know how to do it here on physics is to break the initial velocity down into a horizontal and into vertical component. So if we have an initial velocity that is having a certain angle with a horizontal, let's say angle theta, then we are able to find the horizontal component of this vector and the vertical component of this vector. How do we find this? Vertical component. How do we find this? By creating the right angle triangle that includes the given angle. And then we know the magnitude of the initial velocity, that may be 15, 20, whatever is the number, and we know the angle. So therefore, this being adjacent, we will use cosine, and as being opposite, we will use sine. And then, as a result of this, we built a table. So now, the first time, this will look like gibberish, but listen carefully, because the more you are listening to the examples and the more you are listening and watching the videos, you will understand it better. So, we have two motions, a horizontal motion and a vertical motion. On the horizontal, we have a uniform motion, and on the vertical, we have a non-uniform motion. To have a uniform motion means that the acceleration is equal to 0. And to have a non-uniform motion means that acceleration is not equal to 0. Okay? But what is the acceleration? Acceleration actually on the vertical axis, if we use the vector sign, acceleration on the vertical axis is equal to the acceleration due to gravity, which, since we are throwing the objects at the surface of the Earth, will be 9.81 meters per second squared going down. Okay? So this is the first quantity that we deal with, and we are dealing it in both sides, the horizontal and the vertical, the uniform and non-uniform motion. Next one is the velocity, because as we have said, we are dealing with kinematics. Kinematics talks about what is acceleration, what is velocity, what is displacement, and what is the time that those are happening. Okay, so now, since we are dealing with a horizontal motion, the direction, that is a uniform motion, the velocity in the horizontal will be a constant value. Why? Because it is a uniform. We have said that in a uniform motion, the velocity is constant. But what is that value? That value actually is whatever is the horizontal component of the initial velocity. So this will be whatever is the horizontal component of the initial velocity. Okay? Now let's move to the velocity on the vertical axis or in the vertical direction. So when we are dealing with the vertical direction, this is what we have, and I will use a different color so that you can see. This is what we have. We have an acceleration that is equal to the acceleration due to gravity at the surface of the Earth. It is everywhere, but we cannot throw a projectile at the surface of the moon or another planet, so we will consider as this being 9.81 meters per second squared going down. This acceleration, the same as every acceleration, is v final minus v initial over time that this acceleration is happening. Okay, the change of velocity over the time that the change of velocity is happening is the rate of change of the velocity. Okay, now if we say that since acceleration due to gravity is going down, we can easily say that this is negative 9.81 equals to whatever is the v final in the vertical direction minus v initial in the vertical direction over time that this is happening. Now, V initial in the vertical direction is this here, okay? VI times sine theta. So from here, we can say that V final in the vertical direction, or simply the velocity in the vertical direction, is following the relationship V initial vertical minus 9.81 t. Do you understand this? We'll take now this relationship here and plot it into the vertical direction for the non-uniform motion. So the final velocity on the vertical direction, or we can just simply say the velocity on the vertical direction is equal to whatever is the vertical component of the initial minus 9.81 t. Okay, I will erase those ones here because I need to know now. I need to write down what is the displacement, because the third quantity that we deal with when we are talking and discussing about the motion of an object is the displacement. Okay, so now, since we are dealing with the uniform motion, the displacement in that axis, x, you can say d horizontal, or you can say just simply x, will be equal to velocity times time, because we are dealing with the horizontal direction, which is a uniform motion. But the horizontal velocity is actually constant, which is the horizontal component of the initial times time. And now, since we know the initial velocity here, now in the vertical direction, how do we know? We know the vertical component of the initial velocity. Then the displacement in the y-axis, or in the vertical axis, being a non-uniform motion, will be V initial time in the formula is plus 1 over 2 a t squared. So plus 1 over 2, since a is g, is a negative 9.81 t squared, y will be VIVT minus 1 over 2 times 9.81 t squared. Okay, so if we kind of rewrite this, whatever we did, in a neat way, I always want you to start the projectile motion actually constructing this table, saying horizontal and vertical. In the horizontal, we have uniform. In the vertical, we have non-uniform. Having a uniform means that acceleration is equal to 0. Acceleration is equal to 0. Having a non-uniform in the surface, near the surface of the Earth, will be having an acceleration due to gravity as negative 9.81 meters per second squared. Why negative? Because acceleration due to gravity is going down. The velocity in the horizontal is equal to the horizontal component of the initial. Velocity on the vertical is equal to whatever is the initial vertical component of the initial minus 9.81 t. And the displacement is, since we are dealing with a horizontal direction, which is a uniform motion, will be v times t. And since we are dealing with the vertical direction and we know the initial velocity will be viv times t minus 1/2 times 9.81 is 4.905 t squared. Those are the 6 equations that we will use to solve any projectile motion that we have. Any projectile motion that we have. So it is 4.905 because 1/2 times 9.81 is equal to 4.905. And sometimes you will see me even writing as 4.91. It's the same thing, it's fine. Or you can go 1/2 times 9.81. It's both ways is fine. Questions? So even as you see it from those equations, as the very first step that we will deal with when we have a projectile motion question is to find the horizontal component and the vertical component of the initial velocity. So as step 1, for everything, it doesn't matter what it is, always start with what is the horizontal component and what is the vertical component of the initial velocity. So find VIH and VIV. How do we find it? We know what is the vector, we know the angle, we know the magnitude, so therefore we construct the right angle triangle that includes the given angle, and we find the components. So let's suppose that we have a case like this. You are throwing an object with an initial velocity of 25 meters per second at 20 degrees with the horizontal. This is what it's a typical question. This is how it starts. So if they're asking you to draw the path of the projectile, assuming that no air resistance and no wind is affecting the motion, then you will draw something like this. So it is reaching the maximum at a certain point, and then the same time that the object travels from the ground to the maximum is equal to the time that it travels from the maximum to the ground, and the distance from the point that you are throwing it until it reaches the ground for the first time, because this is the object of projectile. So until it reaches the ground for the first time, it's called range. At the maximum, the range at the maximum is divided into 2 equal parts. So half of the range is from the point when you are starting until the maximum, and the other half is from maximum until it reaches the ground for the first time. Okay, so the very first step is let's find the components and build the equations of the projectile motion. So we have a vector that is with magnitude 25 meters per second and is making a 20-degree angle with a horizontal. So from the tip of the vector, we construct the right angle triangle. Whatever is on the horizontal will be the horizontal component of the initial, and whatever is on the vertical will be the vertical component of the initial. Since the horizontal is the adjacent, we will use cosine, and since the vertical is opposite, we will use sine. So now in your calculator, tell me what is the horizontal and what is the vertical component of the initial velocity? Yeah, it's 23.5 meters per second and 8.6 meters per second. 8.60, that's fine. Okay, so now after we have those two values of the given initial velocity, we will construct the table. Okay, the table is saying with using those values, horizontal and vertical. But I still want you to write, this is uniform and this is non-uniform. Why do I need you to write this? Will help you even on physics 30. Believe it or not, on physics 30, you will have an electron moving into a electric field, and then they will ask you what is the principle that you use first. And if you have it there, you don't have to think longer on which one did you use first, the uniform or non-uniform. It is only 5 seconds to write those down, and it saves you a lot. And then the horizontal component will be whatever is the horizontal component of the initial velocity. That is, in our case, 23.5. And the vertical component will be whatever is initial, 8.6 minus 9.81 t. And for the displacement, we'll go 23.5 times t, and y will be 8.6 t minus 4.91 t squared. Questions up to this point? Having now this table, and I will just label them: equation 1, equation 2, equation 3, equation 4. Equation 5, equation 6. Having this table now, it makes us to solve any projectile motion question, because what we will do is we will just say which equation are we using and what are you substituting it for. So let's suppose if I'm telling you, well, let's find when the velocity is equal to 0, the vertical velocity is equal to 0, which is the same as me asking you what time the maximum is reached. So when I'm asking you what time the maximum is reached, or at what time the vertical velocity is equal to 0, then what you will do is you will take a look at those 6 equations and say, which equation do I have to use to find that time? And I want some answers here. Good. It is equation 4, because this is the relationship for the vertical velocity is given by equation 4. So then we will go 0 is equal to 8.6 minus 9.81 t, and this is the time that the maximum is reached. From here, we find that the time that the maximum is reached will be whatever is 8.6 divided by 9.81, and it is 0.88 seconds. Is this clear? So we found the time that the maximum is reached. However, if I'm asking you to find the total time, for the questions of that is ground to ground, so not from a cliff, a question that you are throwing an object from the ground and it is still hitting the ground, and those are known as the ground to ground question. The maximum, as we mentioned it before, is reached at the half time. So the time that it needs to go from the starting point to the maximum, and from maximum till it hits the ground for the first time, is the same. So if we are looking for the total time, we have two options here. Option one is to take the maximum time and multiply it by 2. So T total, but only for ground to ground, will be 2 times T max. And this will be 2 times 0.88, which will be 0.88 times 2 is 1.76 seconds. So this is telling you that the object is staying in the air for 1.676 seconds. However, there is a second option, and option 2 is using your calculator. With the projectile, we will use our calculator a lot. Calculator. Okay, so what does that mean is we go to the equation here, and the equation that we will use will be equation 6. And then we'll plot in or find out y1 is equal to 0, and y2 is whatever is the equation 6. So that in our case is, and we will find when you graph it, you will see something like this. We will find the time here. Go to your calculator and find that time, and then you will see and compare it, and you should have 1.76. Okay, so the third asking on a typical projectile motion question will be, what is the range? Which means we will find this one here. So this distance here, if you have an object that is thrown with an initial velocity like that. This is the range that we will find. And now, which equation do we have to use to find this range of the projectile? 1, 2, 3, 4, 5, or 6? I want some answers on the chat. On the answers, I see some 5s. That means that what do you have to think is this, in which direction? First of all, is a velocity, is displacement, is acceleration. This is what you have to think. And since I'm asking you how far is it going, then is a displacement. So you will go to the third row of the equations. And then you will say, this range is in the horizontal or is on the vertical. And since it is in the horizontal, then the equation that you will use will be 23.5 T. And then, so you bring this equation, which is equation 5. Now, what is the time that you are substituting? Is the T total or is the T max? Answers here. Yes, it is T total. It is T total because you are looking for what is the time that the object starts, is in the air, when it starts, and when it hits the ground for the first time. So then you will go X, or the range, will be equals to 23.5 times 1.76. And 23.5 times 1.76 will be 41.4. 41.4 meters. This is how far the object will go from the point that you are throwing it until it hits the ground for the first time. Do you have questions on this? Next, asking on a typical projectile motion is, what is the maximum height? So you will find what is the maximum height. So this is a bit tricky because you are looking for height, like, and which equation is your best gut feeling leading to? Equation 1, 2, 3, 4, 5, or 6? Yes, it is 6. It's 6 because you are saying that, well, I'm looking for a displacement. So then I will pick either equation 5 or equation 6. But displacement, in which axis I am looking at, horizontal or vertical? Since I'm looking for the maximum height, then I'm looking for the vertical, so I will pick equation 6. And equation 6 is 8.6 t minus 4.91 t squared. But what am I substituting t for? T max or t total? Questions, answers here on the, it is t max, good. So this will be the maximum height. Maximum height will be 8.6 times, what did we say, 0.88 minus 4.91, 0.88 squared. So 8.6 times 0.88 minus 4.91 times 0.88 squared. And this is what the calculator is giving me. The maximum height is 3.77 meters. This is telling you that the maximum point here, if we refer to this picture, this height here is 3.77 meters. Do you have any questions? So a typical projectile motion question will always start with, and especially when it is ground to ground, we will start with finding the horizontal and vertical component of initial velocity. And then, so this will be step 1, and then using those general equations that we constructed and that we know the logic that stands behind them, we'll substitute those values into the general equations that we are building for the horizontal and the vertical components of the projectile motion. Knowing that in the horizontal we have a uniform motion, and on the vertical we have a non-uniform motion. Having a uniform motion means acceleration is equal to 0. Having a non-uniform motion at the surface of the Earth means that we have an acceleration equals to the acceleration due to gravity, that is a negative 9.81. Why negative? Because it is going down. And then the velocity in the horizontal will be equal to whatever is the horizontal component of the initial velocity. Whatever value you found here, you will plot it here. And for the vertical, we will have whatever you found for the vertical component, vertical component of the initial velocity minus 9.81 t. That means that the velocity is changing. It's changing because it is a non-uniform motion. And whatever value you found here, you will substitute it into this equation. And then last will be the range is following the equation of the horizontal component of the initial times time, because we are dealing with the uniform motion, and the vertical displacement is following VIVT minus, I will just go 4.991, which is 1/2 times 9.81. 91 t squared. After we have those equations, equation 1, equation 2, equation 3, and equation 4, equation 5 and 6, for every question that they are asking, we will say, what is the equation that we are using following the information that is given? If they are saying what is the maximum, maximum is reached when the velocity on the vertical is equal to 0. If they are asking what is the range, then it's equation 5. If they are asking what is the maximum height, then we will use the equation 6, substituting the time that the maximum is reached. And when we are using the range, we will use the total time. Question?